Alright, welcome. Video 3.4, looking at calculating percent by mass. Main objective, understand and calculate what percent by mass is of a given element in a compound. Turn off the phones, turn off the social media, pause, rewind when needed, and take notes in the margins if you need to. Here we go. Percent by mass, or mass percent. Percent by mass is the percentage breakdown of each element in a compound. The way you do that is you take the mass of the element in the compound, divided by the mass of the whole compound, and times it by 100. And you should report this for each element in the compound. So let's take a look at an example here. Alright, so here we're calculating the percent by mass of each element in ethanol, C2H5OH. So there's kind of a nice systematic way to do this to make it work really well for you, and here's how I suggest you do it. List out all the elements you have. So you have carbon, hydrogen, and oxygen. And the hydrogens appear in two spots. We're going to combine those together. So we have 2 carbons, we have 6 hydrogens, 1 oxygen. Now multiply them by their mass, 12.01, 1.01, 16.00. And you end up with numbers of 24.02, 6.06, and 16. Now if we add those masses downward like this, we get the molar mass of the compound. You get 8, 0, 6, and 4. So 46.08 is the mass of the whole overall thing. Now percent by mass, going to the previous page here, now you take the mass of each element and divide it by the mass of the compound and times it by 100. So we're going to take each of these numbers here and divide them by 46.08, each of them. So the element divided by the mass of the compound. And then we times them by 100 because that gives us the percentage we have of each of those. Like so. So, for the first one, we end up with what's my calculator sounds like? We end up with approximately 52.13%. For the next one, we end up with wrong number, 13.2%. And for the last one, we end up with 34.72%. And make sure you label them. That's the percentage of carbon, hydrogen, and oxygen. So a percent by mass problem really should have every single element broken down by percent, and these should round very close to 100% with respect to maybe some sig fig issues. So let's go ahead and just try that really quick. And if we add those together, we end up with 100.05%. And part of the problem there is sig figs. I had 3 sig figs here, so I rounded this to only have 3 sig figs. So that's part of the problem there. So that's close enough, and that is our percent by mass. Now, because we can take a chemical formula and convert it into percent by mass, we should be able to go the other direction. Okay, so percent by mass can be determined experimentally, and we can actually eventually turn those experimentally determined percent by masses back into chemical formulas. And that's what the next videos will do. We will look at taking experimental data and working it back into the chemical formula. I do encourage you to read page 96 and 97 just to kind of look at some experimental methods for how we can figure out percent by masses. Alright, good job.